Problem 30 on page 532. So the half-life of aspirin in your bloodstream is 12 hours. Good. How long will it take for the aspirin to decay to 70% of the original? How long will it take to decay to 70%? You have to write the model, which is this. This is a must. This is the first step. The second step is you can use the formula directly, as we developed it many times. K equals natural log 2 divided by H. So this is confusing because this is the notation for the half-life and this is the notation for hour. They're not the same. It's the same letter. So maybe we should write hours so there is no confusion. So this is the half-life and this is 12 hours. So over the half-life. So you can use the formula, which is fine. So K equals natural log 2 over 12. And this is this K here. And it has to be a negative number. I'm sorry, this is 1/2. So it's 0.5. It's not 2. It's 1/2 or 0.5. That's the formula. Okay, so good. So we have natural log. Remember the answer for the decay, it has to be a negative number. So divided by 12. So this is, and always take 4 decimal digits, negative 0.0578. 0577, but the next digit 5 is 6, so that's why is 0.0578. So now I have the entire model. So the model is A of t equals the original times e to negative 0.0578 t. And now the next step is not a difficult one because now this is 70% of the original. So 0.7 A0 equals A0 e to negative 0.0578 t. And of course, we do not have the original, but we don't even need it. And when I apply natural log again to both sides, I get natural log of 0.7. And this is negative 0.0578 t. And I divide. This better be a positive number, because this is the time required for this quantity to become 0.7 of that quantity. So it has to be, the time always has to be positive. Just the decay rate is negative. So natural log of 0.7. Remember, you have to write parentheses in the calculator. I don't have to write the parentheses here. But if you don't put the denominator in parentheses, the calculator, some calculators, maybe some will, I don't know, but I highly recommend parentheses. I don't think it will, we can try. Just, it made me curious now. It should not work. But, so 0.7 divided by, so when it's half, it's 12 hours. Right? So, but it decays to 0.7%, it's not half. So it should be less than 12 hours. So divided by negative 0.0578. Or just copy the previous answer. Okay? Okay, so 6 hours. From 100% to 70%. From 100% to 50% is 12 hours. But from 100 to 70% is only 6.2 hours. So t equals 6.2 hours. Now, I'm just curious to see what happens with the calculator. What does it do? if I just do this, it should scream at me. It should not accept this. This is not okay. This is not okay. Because no two operation symbols should sit next to each other. This should not be the case, but as I said, some calculators somehow accept it. So again, to reduce to 50%, 12 hours. To reduce to 70%, less, of course, 6 hours. Of course, if we want to reduce it to 30%, it will definitely be more than 12 because it's less than 50%. So these decay rate problems look difficult, but really you should not get scared of them at all. You can use the formula. So it's not 2. Sorry about that. It's 1/2 or 0.5. Good. It was a good one. Any other topic from the entire class? Anything? Anything?